Welcome to third part of this lecture. So in this lecture we'll discuss about designing logic circuit using multiplexer. So here if you can look at the question, so it suggests use a diagram to show how a 3-to-1 multiplexer may be constructed from 2 to 1 multiplexer. Okay, so you can use 2-to-1 multiplexer, that means 2 input 1 output, to design a 3-to-1 multiplexer. So obviously for that you need 2-to-1 multiplexer, right? Okay, so this is the typical diagram, how it looks like. So if you just look at the first one, this is obviously a 2-to-1, this is also a 2-to-1. So you need to make the connection. So this is your S0 control pin for this one S1 control pin for this one, right? So this is your output. So if you look at here, I0, I1, I2, so this is your 3 input and 1 output. So you may call 3-to-1 multiplexer, right, from 2-to-1 multiplexer. So you need to describe the truth table for that, how it works. So as you have 2 control pin, S0 and S1, so you have 4 combination. 2 to the power 2 means 4 combination. The combinations are 0, 0, 0, 1, 1, 0, 1, 1, right? So just look at here, S0 and S1, 0. So 0, 0. If this one is 0, so it will select I0 to output. So this is the output, right? This is also selecting this one to output, right? So the output will be then I0, because here I0 is passing to the output. 0, 1. So if 0, 1, so that means S0 is 1 and this one is 0. So this 1 means this I1 is connecting to here, right? And also this 0 is connecting to here, so it's passing through this path, right? This path, 0, 1. Similarly for other two, for 1, 0 is output is I2, and for 1, 1, actually this is also I2, because it says 3-to-1, so we just have I0, I1, I2. We don't have the last combination 1, 1. So you can put it as don't care, or you can put it as I2 as well. This is your assignment. It suggests to design a 8-to-1 multiplexer using 2-to-1 and 4-to-1 multiplexer. So from the previous concept, I think you can do it by yourself. So you need to draw the diagram, and also you need to show the truth table for that. This is n by 2 input mask. Using n by 2 input mask, you need to implement this function. So this is pretty straightforward as well. So you have 3 input. So for 3 input, you have 2 to the 3, 8 combination of input, 8 combination. So obviously you have 8 output as well, right? So that means, but it says n by 2, that means you have 8 inputs, so 8 by 2, that means 4. So you need to design this function using 8 by 2 means 4 input, that means 4-to-1 multiplexer. So using 4-to-1 multiplexer, you need to implement that function, right? Okay, so for that what you need to do, so just if you look at here, so it's given this is sum of product 1, 2, 6, 7. So if you initially write the 0 to 7, this is the 8 combination. So 1 is high, 1 is high, 2 high, 6 and 7 high, and other low, right? And take 2 at a time, right? These 2, and next 2, these 2 and these 2. Just if you look at here, first 2 is 0, 1, and second 2 is 1, 0, third 2 is 0, 0, fourth is 1, 1. So we consider 1, 1 as F1. F is our output. 0, 0 F F0. And we consider 0, 1 as Z. So 0, 1, that is our Z. So if 0, 1 Z, 1, 0 is Z prime, right? Okay. Now For 4 to 1, obviously you have here 4 input, right? 4 input and 1 output. To select 4 input, you need 2 selectors because 2 over 2 is 4. So this is our selector and this is our data. So if you look at here, like 0, so our 0 and 1, so this is our F0 actually. So this is our Z, and for 1, this is our 1. So this 2 is 1 actually. This is the Z prime. So this is third, I mean 0, 1, 2. This is 2, second output. So this is 0, 2 is connected to 0, and this third one, I mean 0 to 3 means third, in total 4 to, so it's connected to 1. It's connected to 1. So if you connect 4 to 1 in this combination, then this 4 to 1 mask will give you the output for this function, and it will be high for 1, 2, 6, and 7, right, at the F. So if you connect LED, then the LED will be high for these values. Okay, so we have similar another example here. So now you have 4 input. So for 4 input, you have to do a 16 combination. So this is a 16 combination, and you have given sum of product. These values will be high. So put these values high according to this number, and later on take 2 at a time. Make a pair 2 at a time. Here also, like 1 1 is 1, 1 1 is 1, and 0 0 is F0, 0 0 is F0. So if we consider 0 1 as D, then this 0 1 as D, then 1 0 as D prime. So this becomes D prime, this becomes G 0 1. So now again, so for this is n by 2, that means 16 by 2, that means 8 input, 8 by 1 mask, right? So you need to use 8 by 1 mask. So for 8 by 1, obviously you have 8 input and 1 output, and to select 8 input, you need to have 3 data points. 2 over 3 is 8, right? So for 0 to 7, so we have output F0 to F7, right? So just for 0 connect to D, 1 connect to G, so this is also connecting to 2, 2 connected to D prime up to 7, connecting to 1, 6 and 7, 1. So connect all of them, right? So if you connect such a way, then this 8 to 1 multiplexer will give you the output for this function, and it will be high for these values for sum of product. So there are a couple of instructions given how you can design it. I already described it, but if you are still confused, you can have a look of this. So this is your assignment for an input multiplexer. So you need to design this function using an input multiplexer. So remember, it's not n by 2. This is n input multiplexer. Another one, n input multiplexer. Another assignment. This is for n by 2, already discussed, but if you're still confused, you can have a look at the instruction here. And this is n by 4 multiplexer, right? So this is another example, but here you have given in terms of this function. It's not in terms of sum of product, right? Then you need to draw the KMF for this, and later on you need to implement this using 8 to 1 multiplexer. So just this concept is new, otherwise pretty much similar to what we discussed before. We drawn the KMF for A, B, A, D, B, D prime, A prime, B, B prime, C. We drawn the KMF, like, right? So I'm not explaining here how we draw the KMF, as I think you already know how to draw the KMF for this function. Okay, so after drawing the KMF, so as you have 4 inputs, so you have 2 to the power 4, 16 input, right? So for 4 input, we have 16 combination, and from this KMF, you know this is 0 to 15, right? So you know all the 1 values, so put all 1 and other as 0. And again, take 2 as a pair, and for 0 0 is 0. Similarly for 1 1 as 1, 1 1 as 1, and for 0 1 as D prime and 1 0, sorry, for 0 1 as D, for 1 0 as D prime, this 1 0 as D prime, similar to the previous one. Okay, so if you get these values, that are put these values here. So as it is 8 to 1, so that means we have 8 input, we have 3 control pin for this 8 input. Just connect this following this combination and we'll get the output. Just look at here, you have F and F prime. So one is active high enable, one is active low enable. So you don't really need to worry about that. You can take any of the output, but your output would be either active high or active low. This is enable pin, active low enable. So whenever it is low, then this IC will be activated. Okay. So designing decoder. The decoder is pretty much similar. You have given a couple of instructions. If you are still confused, you can have it. So here you have given another assignment. So you need to design this function using 3 to 8 decoder. So 3 to 8 decoder, this is also pretty much similar to what we discussed before, the multiplexer things. So for this one, you need to put high for these values, and you need to draw the circuit first, IC diagram, and later on you need to draw the truth table as well, and from there you need to put these values as 1, other values as 0, and you need to make a pair what you've done before, and you can finally get the connection for all the values. This is pretty much similar what we discussed. This is another assignment, but you need to use 2 to 4 decoder. So using 2 to 4 decoder, you need to implement this. This is another task for you. That's all for this lecture. So I think right now you can design the multiplexer, demultiplexer, encoder and decoder for the given function, right? So function can be given in terms of soft term or in terms of like post term as well. So from there you need to design the function. So these things will be helpful for your lab as well, because in the lab you have set up from this lecture as well. Okay, thank you.